Okay, example 2, same thing, we're going to graph 2 periods of each function. Okay, we're going to start with the function y equals negative secant of x minus pi over 2. And we're going to graph that first by graphing the reciprocal function, which would be negative cosine of x minus pi over 2. All right, so let's think about how we would graph this. Okay, first amplitude. Secant doesn't have amplitude. However, cosine does. So the amplitude of this function is 1. Okay, period is 2 pi over b. Okay, in this case, b is 1, right? We have, here's a, here's b, and here's h. Okay, and same thing for this one, the period would be 2 pi. Okay, we do, however, have a phase shift, right? And that's the big one. That really is the one that kind of messes things up. Okay, so this graph is going to be shifted pi over 2 units to the right, which means, okay, and I'm going to start right now just kind of focusing on cosine, although these are all going to be the same for cosine and sine. Okay, so my starting point, I'm going to write it over here even though I'm talking about cosine. Okay, the starting point, I'm shifting my function right pi over 2 units. So instead of starting at 0, I'm going to start at pi over 2. Okay, my period is 2 pi, so instead of ending at 2 pi, I'm going to end at 2 pi plus pi over 2. We need common denominators here. Okay, so I'm starting at pi over 2 and I'm ending at 5 pi over 2. So let me lay this out first. Okay, so I have this graph. I'm going to start for my first period at pi over 2, and I'm going to end at 5 pi over 2. Okay, so it's going to be my first period. To figure out the distance between the critical points, I take my period, which is 2 pi, and I divide it by 4. 2 pi divided by 4 is pi over 2. Okay, so the distance between my critical points is going to be pi over 2. Okay, so my first critical point is pi over 2. Okay, so to find my second one, since the distance between my critical points is pi over 2, I'm going to add pi over 2. So it gives me 2 pi over 2, just pi. Okay, so then to find my next one, I'm going to add pi over 2 again. Okay, pi is the same thing as 2 pi over 2, or I could get common denominators, whichever way I want to do that. But since I already know that pi is 2 pi over 2, and that'll give me common denominators, I'm just going to write it that way. Okay, so if I add that together, I get 3 pi over 2. Okay, and then to find my last critical point in this period, okay, I would add these together. 3 pi over 2 plus pi over 2 is 4 pi over 2, which is 2 pi. Okay, sorry, that wasn't my last critical point. I've got one more. And just to verify this, okay, 2 pi over 2 is the same thing as 4 pi over 2. So I'm going to say 2 pi plus pi over 2. Okay, remember 2 pi is the same thing as 4 pi over 2. That is 5 pi over 2. Okay, so I'm good. I know that my math is right. My critical points are right. Okay, now I need to go in the other direction. So I would say pi over 2 minus pi over 2 because now I'm moving left. Okay, so my next critical point is at 0. Okay, then I'm going to subtract pi over 2, so I have negative pi over 2. Okay, negative pi over 2 minus pi over 2 is negative pi. Negative pi minus pi over 2 is negative 3 pi over 2. Okay, so there's all my critical points for 2 full periods. Okay, cosine has an amplitude of 1. This graph has an amplitude of 1. I don't have a vertical translation, so my midline is going to be my x-axis. Do, however, have this negative in front, so that's a reflection across the y or the x-axis, so that's going to change things up. Okay, so here's my starting point. At my starting point, because this is cosine, usually I start at the max, but because it's reflected, I'm starting at the min. Okay, up to my midline, up to my max, midline, min. Okay, so there's one period of that cosine function. Then here I'm going to my midline, to my max, to my midline, to my min. Okay, there is another period of that cosine function. All right, so now that I've graphed cosine, I can focus on secant. Okay, everywhere cosine is 0, secant is going to be undefined. Okay, and then I can just fill in my secant graph. Okay, that looks like that. If I'm asked to write the equations of my asymptotes, I can. I don't really have room on that page, so I'll just write them on this page. Okay, asymptotes. Right, they're vertical lines at x equals negative pi, x equals 0, x equals pi, and x equals 2 pi. So those are the equations of my asymptotes. Okay, I'm going to try to fit one more in before the video runs out, or the time runs out. We'll see. Okay, let's look at graphing y equals the cosecant of 2x minus 1. Okay, so to graph this, since sine is the reciprocal of cosecant, I'm going to first graph that function. Okay, so this function has an amplitude of 1. Okay, cosecant does not have an amplitude. It has a period of 2 pi over 2. Okay, so a period of pi. There's no phase shift in here, which is nice. There is a vertical translation though. Okay, so let's lay this out. Okay, I don't have a phase shift. My period is pi, which means I'm going to graph from negative pi, okay, to positive pi. To figure out my distance between critical points, I'm going to take my period and divide by 4. Okay, so if I'm starting at 0, one full period would be 0 to pi. The distance between my critical points is pi over 4. Okay, the distance between 0 and pi over 4 is pi over 4, so there's my first one. Okay. Then to get the next one, I have pi over 4 plus pi over 4. That's 2 pi over 4, which is pi over 2. Okay, then I need to do pi over 2 plus pi over 4. I already know that pi over 2 is 2 pi over 4. So if I add those together, I get 3 pi over 4. Okay, and if I were to add a 4 pi, or a pi over 4 here, it would give me 4 pi over 4, which is pi. Okay, going in this direction, 0 minus pi over 4 is negative pi over 4. Negative pi over 4 minus pi over 4 is negative 2 pi over 4, negative pi over 2. Okay, minus pi over 4 is negative 3 pi over 4. Okay, I do have to take into account this vertical translation. My function is shifting down 1 unit, which means that my midline, I'm going to draw this in a different color. Okay, my midline moves from the x-axis to y equals negative 1. Right, so my midline becomes y equals negative 1. Okay, so I'm going to graph this function first. There's no negative, so I don't have to worry about a reflection. Okay, when I graph the sine function, I start at my midline. I go up to my max. Okay, my amplitude is 1. That means my max is 1 unit above my amplitude, so that would be 0, or above my midline, so that would be 0. Back to my midline. Okay, down to my minimum, which is 1 unit below my midline, and then back here. Okay, so one period of that sine function looks like this. Continue on the pattern, minimum, midline, maximum, midline. Okay, now I can graph this cosecant function anywhere sine equals 0, right? Cosecant is undefined. Okay, and that is incorrect. And maybe I should rephrase that. Let me just put this back in here. Okay, and by 0, really that's where sine is crossing the midline, okay? And if you evaluate that, you will see that. Okay, so anywhere sine is touching that midline, that's where you're going to get your asymptote. And keep doing that wrong. Let me try it again. Okay, anywhere sine is crossing the midline, that's where you're going to have your asymptote. Okay, so you're going to have to be careful of that so you don't make the same mistake I just did. Okay, it's not necessarily where it touches the x-axis, it's where it touches, or where it crosses, okay, that midline. So that's where my asymptotes are. Okay, so now to graph cosecant, everywhere sine touches its max, okay, cosecant is equivalent to that. So those points are going to be the same. The max and min points are the same for secant and cosecant, or sorry, sine and cosecant. Okay, so where sine has a max, cosecant has a min. Where sine has a min, cosecant has a max. Where sine has a max, cosecant has a min. Okay, where sine has a min, cosecant has a max. And I may run out of time on this, but if you're looking for your asymptotes here, okay, they are the points where it crosses the midline. So that would be negative pi over 2. Okay, these are vertical lines, so x equals negative pi over 2, x equals 0, x equals pi over 2, and x equals